All right, let's talk about factoring and solving now, section 3.6. So we're going to factor quadratics, and then we're going to take it that one step further and actually figure out what x equals. Before we begin, let's talk about the GCF, or the greatest common factor. It's just the highest number or variable that divides into all of your terms. So looking at the first example, 5x to the fifth plus 10x to the third. Both of the numbers are divisible by 5, so we want to divide a 5 out. And you'll notice we have 5x's here, we have 3x's here, so I can take at most 3x's from both of those terms. So my factored form, if I take out the GCF, I'm going to put the GCF right here, and I'm going to put whatever's left over in the parentheses. So starting with the first term, 5 divided by 5 would give me 1. I had 5x's, so I'm looking right here. I had 5x's. I took 3 out, so that means I have 2 left. Plus 10 divided by 5 is 2. I had 3x's. I took 3 out, so there's no more x's left. So this would be, oh my goodness, that would be factored form. Now, technically, I don't need, oh my goodness, I don't need that 1 there. I can just leave it as x squared, but if you really want it there, that's fine. It also works the same way for 3 terms, so you look at these 3 terms, what are they all divisible by? Starting with the numbers, it looks like they're all divisible by 2, and I can take 1x out because I only have 1x right here. So here's my GCF, put it here on the outside. Let's put what's left over on the inside of those parentheses now. 4 divided by 2 is 2. I had 3x's, I'm taking 1 out, so x squared. Minus 2 divided by 2 is 1, so you can put it there if you want, but I will just have 1x left over, and that would be the little more clean way to write it. And last but not least, 6 divided by 2, so is 3. I had 1x, I took 1x. There you go. Now, technically, when you have a trinomial left over, you should try to factor that even further. And in this example, we could, but for right now, we're not going to. We'll get into that maybe a little bit later here. The other thing I want to get into first before we talk about solving is special patterns. So this one's called the difference of perfect squares. So the key here is you have to subtract 2 perfect squares. You also have to know what perfect squares are. So you see a situation like this. 121x squared is a perfect square. 16 is a perfect square. And we just happen to be subtracting those two. So I can use a shortcut here instead of the box method, which is going to save you a ton of time. Because if we were doing the box method, you would take A times C, 121 times 16, is 1,936. And then you'd be finding factors of 1,936 that add up to 0. Since there's no B term, it would be 0. And that could be a lot of work. So if you recognize it's a special case, let's just jump to the shortcut. Starting with here, the square root of 121x squared is 11x. So 11x times 11x is 121x squared. The square root of 16 is 4 times 4. And then in order for my B term to be 0, one of these has to be positive, the other has to be negative. That's it. That is the shortcut if you recognize it's a special case, because we want to avoid that. Okay, next example, x squared is a perfect square. 25 is a perfect square, so I'm going to jump right to the shortcut. So the square root of x squared is x times x. Square root of 25 is 5 and 5. One's positive, the other's negative. So there's 2 more examples there if you want to try. But yeah, that's basically it. We'll skip that. We'll jump right to example number 5 here quick, just to try to get a few in and hopefully not take up too much of your time. So when you solve, the first thing you want to do is make sure your equation equals 0. If it doesn't equal 0, we'll have to move some terms around in order to begin solving. So step 1, equation should equal 0. Step 2, look for GCF. Step 1 equals 0. Step 2, GCF. So if you look at all of these terms now, do they have anything in common? No, they don't. So step 2 is done. Step 3, factor. So I'll label A, B, and C for you. We talked in the last video that if A is 1, because it is, A is a 1 there, you can use a shortcut to factoring here. You just don't have to draw the box. It saves you a little bit of time, but not much. If you don't like the shortcut, the box will always work. Okay, I'm going to use a shortcut here, though. We still have to take A times C, so 1 times negative 15 is negative 15. And then we're looking for that factor pair that adds up to negative 2. And this one shouldn't be too bad. Again, it takes practice. If you want, list them all. So negative 1 times 15, 1 times negative 15, negative 3 times 5, and 3 times negative 5. Those are all the factor pairs of negative 15. So you can list them all if you want. The more you practice, the easier this will get. You look at the first one. If I add these up, I get 14. Not going to work. Second one, add them up, I get negative 14. Not going to work. The third one, I get positive 2, which is really, really close. I just need the opposite sign, which means I need to flip my sign. And there it is. So because A is 1, I can say that my factored form would be x plus 3 times x minus 5 equals 0 now, because it's an equation. Okay, so step 3, factor. Step 4, now we just need to solve. And here's the new part. So the factoring is what we covered in the video yesterday. Now we got to take it all the way to finding what x actually equals. So once you've factored it, take each factor, set it equal to 0. So we'll take x plus 3, set it equal to 0, that's the first factor, and solve for x. Subtract 3, boom, found one answer. Then we take the second factor, x minus 5, set it equal to 0, x equals 5. Boom, there you go. It's that easy. Let's try to find another one quickly. I'll do some from the student example here because I'm going to have you do work out of the workbook instead. So student example 1, we'll just look at the left side. So the first thing you want to do is make sure your equation equals 0. Right now, obviously, it doesn't. So we need to move negative 4x and 10 to the other side. We can do that all in one step here. So we'll add 4x and subtract 10 all in one step here. So then we end up with 2x squared plus 7x minus 15 equals 0. So it equals 0. We're good to go. Step number 2, greatest common factor. Do these three numbers have anything in common? Oops, no, they don't. So now we're moving on to step 3, which is where we actually have to factor. So we have A, B, and C. A is 2, so we can't use the shortcut, so I'll go ahead and get this set up. Okay, my first term is 2x squared, that goes in the first box. My last term is negative 15, that goes in my last box. Now, off to the side, we're going to take A times C, and we get negative 30. Factors of negative 30 that add up to 7. So again, if you don't know, list them all out and then do the addition later. If you're kind of getting the hang of it now, you can kind of just jump to the correct factor pair. Just write it out for me so I can see it. But I'm trying to get to 7. You're probably playing around with numbers like 5 and -6, and you get 1 or -1 depending on where the sign's at. So that's not going to get you there. 2 and 15 won't get you there. How about -3 and 10? If I add those up, I do get +7, so that's the correct factor pair. So we'll finish the box out with -3x and 10x. Again, the order of those two numbers doesn't matter. The first term and the last term do, but those two do not. And then from here, we're just finding the greatest common factor. So along the top row, 2x squared and -3x, they just have an x in common. Along the bottom row here, 10x and -15, we can divide a 5 out of both. Up the left column, 2x squared and 10x, they both have a 2 and an x in common. And last but not least, up that right column there, we can divide both by -3. So my final factored form will be 2x minus 3 times x plus 5 equals 0. So we did the factoring. The last step now, the new step is to solve. So take each factor, set it equal to 0. There we go, 2x minus 3, set that factor equal to 0, solve for x. And sometimes you'll get a fraction, not a big deal. And then take the other factor, x plus 5, set it equal to 0. That's called the zero product property. Okay, and there you go. Now the last example I'm going to do here is right below it, x cubed plus 8x, or 12x squared minus 8x equals 0. So the first step is make sure your equation equals 0, and we are good there. Now what we want to do is look for the greatest common factor, and for the first time, we actually have something we can divide out. All three numbers are divisible by 4, and we can take an x out of each of those as well. So here's my GCF. Here's what's left over. 8x cubed divided by 4x will be 2x squared. 12x squared divided by 4x will be 3x. Don't know what happened here. Oh my goodness. And 8x divided by 4x is 2. So we have our GCF factored out, and as I mentioned earlier, you should always try to factor out what's left over in the parentheses if you can. And in this example, yes, we can. So let's take a look here. We'll just ignore the GCF for a second. Let's take a look now. We have A, B, and C. A is not 1, so we'll have to use a box. There's my first term in the first box. My last term in the last box. And we'll take A times C. This one won't be too bad. A times C is -4. We are trying to get to +3. And this is one of those, hopefully you can tell me right off the bat that the two numbers we're looking for are -1 and 4. You add them up, you get +3. So that's how we'll finish filling out the box. All right, along the top row here, 2x squared and -1x, they just have an x in common. 4x and -2, bottom row here, they are both divisible by 2. Up the left column, we have 2x squared and 4x. Those are both divisible by 2x. And up the right column, we have -1x and -2 even though it looks like they have nothing in common, you can always take out a 1, and in this case, because they're both negative, a -1. So factored form would be 2x minus 1 times x plus 2 equals 0, and then to finish it out, just set each factor equal to 0. Oops. Oh, hold on. I said we'd forget about it. I forgot about it too long. The GCF, you can't forget about it. You want to bring it down here to your factored form, because we also have to set that factor, 4x, equal to 0 as well. And that'll give us a third answer this time. So 4x equals 0, divide both sides by 4x equals 0. So there we go. Now I can take my second factor, 2x minus 1, and set it equal to 0. So add 1, 2x equals 1, x equals a half, and then x plus 2 equals 0, x equals -2. And there you go. That is solving by factoring.